Hi, I am Randall O'Neill, and I am here to show you on how to solve one problem of the fundamental of deformable bodies, specifically about the topic stress and strain axial loadings. So, without further ado, let's get into it. Stress and strain axial loading. So before we proceed to our solution, we need to define first what is stress and what is strain. So here's the definition. Stress is the measure of an external force acting over the cross-sectional area of an object. Stress has units of force per area, which is Newton per meter squared or pounds per inch squared. The SI units are commonly referred to as pascals, abbreviated as PA. Strain is the ratio between the deformation and the original length. Deformation is a measure of how much an object is stretched. Strain is a unitless and is denoted by the Greek letter epsilon. This epsilon is also equals to delta divided by L. Let's consider this problem. This is problem 2.10. A block of 250 mm length and 50 by 40 mm cross section is to support a centric compressive load P. The material to be used is a bronze for which E or modulus of elasticity is equal to 95 GPa or gigapascal. Determine the largest load that can be applied knowing that the normal stress must not exceed 80 megapascal and that the decrease in length of the block should be at most 0.12% of its original length. So before we proceed to our solution, we need to identify first the given. So based on the problem, the first given is the length, which is 250 millimeter, and we also have the cross-sectional area, which is the quantity 50 by 40 millimeter squared, or 2000 millimeter squared, or this can also be equal to 0.002 meters squared. We also have the E, which is the modulus of elasticity, which is 25 gigapascal, and also normal stress, which is 80 megapascal, and also the decrease in length, which is E or epsilon or equal to delta over L, which is 12% or 0.0012. Our goal here is to find the largest load that can be applied to the block, and we have two conditions here that we need to consider, which is based on stress and strain. That means we have two separate solutions due to these two conditions, but the minimum value of these two will be considered as our allowable load or as the maximum load. The solutions will be shown in this portion, step by step, so I hope you pay attention to it. Our first solution is based on stress. So given that the equation for normal stress is sigma is equals to P over A, then we can derive P from this equation. So P is equals to sigma times A. Then from this equation, we can now substitute the given that we found previously. So P is equals to 80 MPa times 0.002 meters squared. So we know that M is equal to 10 to the 6. Then our equation would be like this. So our goal here is to have a final result with a unit of Newton. So in order to get a unit of Newton, so we need to convert PA to Newton per meter squared. So given that 1 PA is equal to 1 Newton per meter squared, then we get P is equal to 80 times 10 to the 6 Newton per meter squared times 0.002 meter squared. So from this equation, or from this step, we can now eliminate meter squared, and then by putting this to our calculator, then we get this result. P is equal to 160 kilonewton. So for our second solution, it is based on strain. So given that the equation for deformation in block is delta is equals to P times L over A times E, we can derive P from this equation. So in order to derive, we can multiply both sides by A times E. Then our equation would be like this. A times E times delta equals to P times L. Then divide both sides by L so that we can get B. So our equation would be like this. P is equal to A times E times delta all over L. Or this equation is also equal to A times E times delta over L. Then from this equation, we can substitute the given that we have previously. So P is equal to 0.002 meters squared times 25 GPa or gigapascal times 0.0012. So we know that G is equal to 10 to the 9. Then our equation will be like this. So again, our goal here is to have a final answer with a unit of Newton. So in order to get the unit of Newtons, we need to convert Pascal to Newton per meter squared. So again, given that 1 Pascal is equal to 1 Newton per meter squared, then our equation will be like this. So P is equal to 0.002 meter squared times 95 times 10 to the 9 Newton per meter squared times 0012 times 0.0012. Then from this equation, we can omit the meter squared unit, and then by inputting this to our calculator, then we get this final answer. It's equals to P is equals to 228 kilonewton. So since we're done with our solutions, so here's the summary. For the solution 1, which is based on stress, the P is equal to 160 kilonewton. And for solution 2, which is based on strain, the P is equals to 228 kilonewton. So, as I have said earlier, the minimum value of these two will be considered as our allowable load or as the maximum load. So, among the two, 160 kilonewton is the smallest value. So, therefore, the largest load that can be applied is 160 kilonewton. So, thank you so much guys for watching this video. So, I hope you learned something about it. So again, thank you so much and God bless. Stay safe.